Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will take a look at the lesson which is related to imputation of missing date components. So in this lesson, we are using 01 for missing day, Jan for missing month for start date, and last day of the month and December for month for end date. So we have an algorithm for imputation of start date and imputation of end date. So this lesson is part of the concept which is called as date imputations of clinical SAS ADaM programming. So let us take a look at the background of dates and date imputations. So in a clinical trial, we collect information related to medical history, prior medication and concomitant medications and adverse events experienced by the clinical trial participants. So for these events or interventions, so we collect the start and end dates of occurrence. Say for example, we collect the start and end date of a particular medical condition, or we collect the start and end date of a specific medication used by the clinical trial participant or the subject. Then we may also collect the start and end date of any adverse event experienced by the clinical trial participant. So often subjects do not remember the exact date and could only partially recollect the dates of all these events or interventions. So for example, the subject may only say, I started using this in 2010, or someone may say like in 2015 January I started using it, or I had experienced some particular medical occurrence. So some may recollect the particular date value as like 10 a.m. between 10 a.m. and 11 a.m. of 15th Jan 2019, but is not sure of the exact time. And some may not even remember the exact date, including any year at all. So in these cases, what happens is this will result in partial dates in the collected data because the date cannot be collected in full. So we are calling it as a partial date or partial date time. So for analysis purposes, we may want to convert these partial dates into full dates or including times using a predefined algorithm. So this process of converting partial dates to full dates for analysis purposes based on predetermined rules is called imputation of dates in clinical SAS programming. So how does ADaM handle these things? So ADaM standard for date imputation related variables. So does ADaM allow for imputation of dates? Yes, ADaM allows for imputation of dates, times and date time values. So we need traceability as per ADaM standard, that is the ability to identify the source values and indicate what changed. So in terms of traceability for date imputation, we have variables to indicate the imputation of a date on a record in the ADaM dataset. So if we are changing or using a predetermined value for partial dates for particular month or day for year if it is missing, so it allows us to change. So it has a variable to indicate what component has changed. Say for example, we have a variable called DTF. Say for example, if we are creating start date for adverse event, we create it in a variable called ASTDT in ADaM ADAE. So for that, the variable for imputation of date is ASTDTF. So I have used a wildcard asterisk here. So DTF stands for date imputation flag. So DTF variable is used to indicate the imputation of date value. If we have imputed a date, so we will populate a specific value in the DTF. And if we have imputed the time, so we indicate that the time is imputed by populating a specific value in the TMF variable. Similarly, if we are creating datetime variables and if we are imputing any of the components in the datetime value, so we indicate it with a specific value on what changed in the DTMF variable. So now these three variables are used to hold a value that represent the highest level of imputation done. So we will see what those possible values are in DTF and TMF and DTMF. So, so the possible values in DTF are Y when year is imputed. Say for example, if the full date is missing or only month and day is collected but the year is missing. So the highest component that is being imputed here is Y. So in that case, we will populate the DTF variable with Y. And in the next case, if we are imputing month, so we populate it with M. Say for example, there can be cases where year and day is remembered, but the month is not remembered. In that case, we are imputing day, but not the month. So we are populating M there. So there can be cases wherein only year is remembered, but neither the month nor the date. So even in that case, the highest level of imputation that we are doing is at month level. So we will have to populate it with the value of M. Similarly, we will use a value D to impute to indicate that the day of the month is imputed. So when only, say for example, in this case of 2015 January, we know the year and month, but the day is not present. So in that case, we'll have to use a value of D. And the possible values in TMF variable are H when hour is imputed, M when the minutes are imputed, and S when the seconds are imputed. So similar to this DTF and TMF variables, DTMF is a collection of both date and time values. So the overall possible values in DTMF variable are Y, M, D, H, M, and S. So now let us take a look at the input data that we will use for this lesson. So we are discussing this lesson using concomitant medications as example, where we have the start date of the concomitant medication and end date of the concomitant medication. So if you take a look at the data, we do have some partial dates. So where in day is missing, where some month and day are also missing in both the start date and end dates. So now let us go to the specification and see the algorithm provided to us to impute the dates. So for ASTDT, so the specification is divided into three components, A, B, and C. The first part says when the date collected is full, so which means the subject was able to recollect the full date, and then in that case what we need to do is convert it to numeric format. So we don't need to do any imputations here, we can directly convert the collected date into numeric format. And the second component says when the day component is missing, which means year and month is present, but the subject was not able to recollect the exact day of that particular month. So in that case, for ASTDT, we are being asked to use 01 for day component and convert it into numeric format. So when only day is missing, the start day of the month is being used for ASTDT. And the third component says when the month and day component both are missing, so it says use first day for month and 01 for first 01 for day component and 01 for month component and convert to numeric format. Say for example, if only year 2009 is collected, we are being asked to populate it with the value of 1st Jan 2009. So now let us move on to the derivation algorithm for ASTDTF. So it says set to M when the month and day components of start date are imputed. So for the second section B, so for the component C, the value of M is applicable wherein both month and day components are imputed. And we are being asked to set to D when day component of the start date is imputed. So for component B, when only day is missing, so when we are creating a new date using 01 for that missing component, so we are being asked to set it with a value of D. So D indicates that D date, only the day of the month is being imputed in the particular date. And now let's move on to the derivation logic for AENDT variable. It says derive the variable using CMENDTC variable. So and when the date collected is full, convert it into numeric format. And when the day component is missing, use last day of the month for the day component and convert it into numeric format. For start date, when only day is missing, we used 01, but for the end date, when only the day component is missing, we are using last day of the month, whatever it could be. Say for example, if it is January, it will be 31. For February, we need to consider whether it is a leap year or not and for populate it with 28 or 29. And for March again, it will be 30, and for April it has to be, for March it has to be 31, and for April it has to be 30. So we'll have to take into consideration of all these values, including leap years or not, when we are imputing this way. And then when the month and day component are missing, use last day of the year for month and day component. So which means last day of the year is 31st December, which means we are being asked to use that value with the collected year. Say for example, if it is collected in 2000, only 2009 is collected. So if we have to populate it with an imputed value, here in this case we are being asked to use last day, which is 31st December 2009 will be populated in the AENDT for the cases where month and day component are missing. And then we have AENDTF, which is analysis end date imputation flag. So again, we are being asked to set to M when month and day components of the end date are imputed, and set to D when day component of the end date is imputed. Now let us move on to the data and then manually try to fill in the values which we will be imputing to. So let us start with start date. So we know that for start date, when only year is present, we are being asked to use the first Jan date. So here the date is full, so we all we need to do is convert it into numeric format, that is 1st Jan 2010. So we have populated it. And then now let us take a look at the second record. It has a value of 01 2010, which means January 2010. So when only month and year is present, we were asked to use 01 for start date. So again, this will also become 1st Jan 2010. So let us fill in that number. So here in the third case also we have 01 and 2010. So that will also be 01 Jan 2010. So again, we have a fourth instance wherein only year is present, but month and day are also missing. As per the specification, we were asked to use 1st Jan when month and day are missing. So this value will also become 01 JAN 2010. So again, there is a record for Feb 2010. So what will this value become? 01 Feb 2010, because we are being asked to use the first of the month when only day is missing. So this is now let us try to populate with ASTDTF. So have we done any imputation on this first record? No. When the date is full, so we are not making any imputation. So this will become null. So here in this case only day component is missing and we have imputed it with 01. So when we have only imputed the day component, what should be the value in ASTDTF? It has to be D. So and here also we have imputed only day component, so it will have a value of D. So here in this case, so only year is present, so we have considered the imputed portion as 1st Jan. So we have imputed it at month level. So the highest level of imputation is at month level, so we'll have to populate it with a value of M. So this is a, and then here for the last record we know the year and month, but day component is missing, so this will become D. And now let us take a look at the AENDT values. So we have 2011, so only year is present, but month and day are missing. For end date, as per the specification, we were asked to use the last day of the year, which is 31st December 2011. So that is how we'll have to populate. So only year is present, month and day are being imputed. So the highest level of imputation is at month level. So AENDTF will become M here. So here in this case, so we have an end date of 2011 November. We do not know the exact date in November. So we know that we have 30 days in November. So we'll have to populate it with 30 November 2011. So what is the level of imputation that we are doing? We have imputed only the day component. So we'll have to populate it with the value of D. So again we have here 12th 2011, which is December 2011. So we know that there are 31 days in December. So we'll have to impute it with 31st December 2011. So we have only imputed the day component because we know the month and year. So what should be the value in AENDTF? It should be D. So here in this case, next is Feb 2011. So is when it comes to February, we need to check whether the year is leap year or not when we are trying to impute with the end date. So Feb 2011, 2011 is not a leap year, so we will have to use 28 as the last day of that month. So 28th Feb 2011. So what is the highest level of imputation that we have done? As we only have missing date, so we have imputed only day component. So it will have a value of D. So now Feb 2011. So 2012 is a leap year. So we need to use 29th Feb 2011. So this is how we'll have to populate the AENDT and AENDTF. So we have now seen how to manually impute the dates and also populate ASTDTF and AENDTF variables as per the ADaM standard. Now let us take a look at the programming that can be used to derive ASTDT and ASTDTF and AENDT and AENDTF. So here in this case, I have created a copy of CM dataset and called it with a new name CM01. So as per the specification, there were three conditions: when the date is full, when month is missing, and when day is missing. So how do we know whether the date is full? As per ADaM standard or as per CD's SDTM standard, so we know that when the date is full, we'll have 4-digit year followed by a hyphen, followed by 2-digit month, followed by 2-digit day. So the overall length will become 10. So when we have 10 characters and there are no data issues in the data, so it means that the date is full. So we are using length function to check whether there are 10 characters in the value present in CMSTDTC variable. When the length is 10, it is means that the date is full. So on that case, all we need to do is convert that CMSTDTC value into numeric value. We can convert that using input function and using YYMMDD 10.in format. So, and then we are moving into the second component of the derivation, which says else if length of CMSTDTC is equal to 7, which means 4-digit year, 2-digit month with a hyphen in between, 4 plus 2 plus 1. So the length will be 7 when we only have year and month. So in that case, so we will have to employ some imputation algorithm. So when for the start date, when we have only month and year collected, we were asked to use 0, 1. So in this case, what we are trying to do is here, we are using the existing CMSTDTC and concatenating 0, 1 to the existing CMSTDTC at the end of that and using hyphen as delimiter using catx function. So this will become, say for example, if we only had like 20110 2010-01, what would happen is we are concatenating the day component as 01 at the end of the existing 2010-01. So we are adding hyphen 01 extra, and then we are converting that value to numeric. So that would have become 1st Jan 2010. So as we are imputing only the day component here, we are populating ASTDTF using D value. And then the next component is next section of the code is dealing with the cases where only year is present in the CMSTDTC variable. When we only have year collected, the length of that value in CMSTDTC variable will become 4. So we are using that logic and then going into the derivation logic. So when we only have year collected in start date, we were asked to use 1st Jan. So what we are trying to do here is concatenate 01 for month and 01 for year to the existing year value in CMSTDTC with hyphen as delimiter between the existing year, month and day components. So, and then converting it back into numeric format using input function. So as month and day are missing, the highest level of imputation we are doing is at month level. So we are populating ASTDTF with the value of M. And then now let us move on to the code which is handling the imputation of end dates. So again, similar to the start date, when the CMNDT is full, the total number of characters in that will be 10. So wherever the length is 10, so we are automatically converting it into numeric using input function of the CMSTDTC value. And then else if length is equal to 7, then which means that year and month are collected but day is missing. So in that case, what we need to do is we were asked to populate it with the end day of that particular month. So the key section is this int_n_x function, so which actually we are making use to fetch the last day of any month irrespective of the year. It takes into account your leap year, so 28-day month or 29-day month or 30-day month or 31 days month. So we'll see how it is being done. So here for int_n_x function we need to give a date first, and then we also need to tell like the next interval date that we need. So we are using this first argument as with the value of month, which means we are asking int_n_x function to return the a specified month's date with the when beginning with this particular date which we are giving here. So here what we are trying to do here is we know that in the end date day component is missing, so we are making a temporary date value using 01 of that particular month. Say for example, if we only have 2011 Feb 2011-02, so we are temporarily converting it into 1st Feb 2010 and then using that particular date. So we are asking SAS or int_n_x function to return a particular date after n number of months. So this a month is for that specified interval. So this is the starting date. So we are converting it into that temporary date into first of that month and then converting it into numeric format. And this third argument is used for specifying the nth interval. So after how many months a date you need. So here in this case we are using, the trick is to use 0, which means the existing month. And then the second trick is to make use of the e argument, e keyword of the int_n_x function of the fourth argument. So E stands for the end of the month. So 1st Feb 2011 is the initial value. So within that month, we are asking to return the end date value. So what would it become? It would take into consideration of the month and year also, and then return the end date of the month. So now let us see what happens when we had passed these two dates with this syntax. So what we were actually trying to do here is, so we had end date, so 11th 2011, which means November 2011. So what we made was the temporary date, we made it as 1st November 2011, and then we asked SAS or the int_n_x function to return the current month's end date using this syntax. So here we have asked 0 is for current month and E is for end date within that particular month. So it would return as the end date value. So if we use this int_n_x function and this logic, we need not write any programming logic to check whether an year is leap year and to check whether the month has 30 days or 31 days, or when it comes to Feb, whether it is a leap year or not. That logic need not be checked. So, and then we will move on to the section where we only have year collected in CMENDTC. So for the end date, when only year is present, we were asked to use 31st December. So here we are concatenating 12 and 31 to the existing CMENDTC with a hyphen as delimiter using cat function and then converting it into numeric format, and then we are also converting, assigning a value of m to the AENDTF variable as per the expectation, even in the previous case. So wherein we were only imputing the end day, when we had month and year collected, we were populating it with a value of d. So this is how we can impute our dates based on the specification given. And there can be different algorithms as per the analysis needs, but this is one such approach. Thank you for watching and keep learning.